Okay, so today we're going to take care of Pythagorean theorem. It's a pretty famous formula. Most people should be aware of this. It's again a grade 9 topic, but it shows up so often. We will commit a whole day to it. And you can see here they have a right-angled triangle. Okay, that's going to be key. This is only going to work for right-angled triangles, so make note of that. This formula is only true for right-angled triangles, and obviously the right angle is down here. It's the square corner, 90 degrees. Another word for 90 degrees is perpendicular. Okay? So make sure you're aware of those terms. And the formula here is stating that the c square is equal to the a square plus the b square. Now, algebraically, that looks okay. Visually, it's actually quite nice, and I'll show you a YouTube video in a little bit here. We'll just do the math first off. They're going to have some definitions up here in the square box here saying that a is the altitude, b is the base, and c is the hypotenuse. That just happens to work out nice, and altitude and base, like if you turn it, they switch, so it doesn't really matter what those are called. This is the hypotenuse, though, which we'll call HYP, hype. So C is the hypotenuse, and you can see it's directly across the 90. Directly across the 90. And it is the longest side. So highlight that in the book there. The hypotenuse is the longest side. And it is straight across the 90. It is opposite the 90. Now the other two, A and B, those can be interchanged. Those are called the legs. So I'll call A and B the legs. Okay, so you need to take the square of the legs and add them up, and you will get the square of the hypotenuse. So let's do a famous one. Let's just do it up in the corner here. This is a famous triangle. It's the 3, 4, 5 triangle. So if you had a square of length 3, what would the area be? Good. You just make a square, 3 times 3. And what about the square for 4? 4 times 4. And then what about the square for 5? 5 squared is 25. And lo and behold, if you add up 9 and 16, you will get 25. Okay? So these two you would add up, and you would get 25. Okay? And I'll show you a visual for that later on YouTube. So for now, we'll just work through these algebraically. Okay, let's take a look at this first one here. You have a 7 and you have a 12. Where is the unknown? The unknown is at x. Is that a leg or a hypotenuse? Okay, good. So for this one here, put unknown hype. If we follow the formula directly, we can do a substitution. When I substitute, I use a bracket. So where I see A, I will put 12 or 7. It doesn't matter. Let's just put 12. And for B, if we put 12 there, this one has to be 7. Order of operations states that we should do the exponents first before adding. You guys recognize this acronym? BEDMAS. You must do exponents before you add. That's order of ops, order of operations. 12 squared is the same as 12 times 12, that is 144. 7 squared is 7 times 7, it is 49. Add those up. Help me out. 193. Okay, so that's the square for C. What that means is that the area of that square is 193, but I want the length of the square. That's what x is. X is the length, not the area. So what is that length that I drew there in black? I would have to do the opposite of square, which is square root. And that's what I'm looking for, the square root of 193. So help me out. I got 13.89. Okay. About. Roughly. There's some rounding in there. That little squiggle I use for approximate. Guys okay with that one? That's the method when you have the unknown hypotenuse. Let's try this one. For this one, I'd like you to put unknown leg. Because the hypotenuse is known, the leg is not. So again, you have this formula. You guys are probably very familiar with it. Let's substitute in what we know. Where do I put the 12? Where I see the C. Remember, C is the hypotenuse. Now for A, let's substitute in x. And for B, let's substitute in 10. Any issues with that, you guys? Does that feel okay? Question? That's exactly where I'm headed. Good man. So we have 12 squared is 144. X squared, we can't do much with that. And 10 squared is 100. Now staring at that equation, what do you want to solve for? Obviously, x. In algebra, what you're trying to do is isolate the unknown. The unknown is x. What does it mean to isolate? If you were alone on a deserted island, would you be isolated? Yeah? Okay, so just in case you're not sure, isolate, you have to be by yourself. So what's the problem here? Is x by itself? So you need to get rid of that 100. How to do that? You want it to go to the other side. A lot of you said subtract. That's amazing. Now if you subtract 100 on the right, what do you got to do to the left? Okay, good. So in junior high, they would be like, okay, let's draw a vertical line like this. You ever see this? And then they're like minus 100, minus 100. You guys okay with that? You've seen that before? Okay, I'm just going to back it up. And then this is what I do. This is how I think about it. I think about it like this. I want x squared by itself, so 100 needs to go away. What does a positive 100 look like on the other side? Right. So this is how I think about it. I think about 100 as a term that appears on the right-hand side as a positive 100. Now, when you switch to the other side, you have to think, what's the opposite of positive 100? And that is negative 100. You can simplify that left-hand side and you get 44. And you're back to where you started with the other question, so you guys can finish that off for me. Okay, so there's the solution, 6.63 after square rooting. Now I'll just show you some shortcuts. I'll show you some shortcuts on the calculator. Alright, so let's go back to the lesson. Okay, we have a wire for ESL. Don't worry about this word, it's a stupid word. You just have a wire, cable or a rope, anything like that, attached to the top of a 10-meter pole and anchored, so it's just like fixed to the ground, 2 meters from the base of the pole. Find the length of the wire. Can ignore this word. So you need a picture. That's the pole. You can put a 10 next to it. And then it's 2 meters. So you just put the 2 like that. 2 meters from the base. Find the length. So we want this dotted line. That's what we want. So go ahead and solve that. Do it quick. I'll do it in one step on my calculator. Square root of 104. This is what you're looking for. 10.2. So I'm just using the shortcut. Pythagorean theorem, you do not have to show all your work. It's pretty quick. So where did the 104 come from? Good. 100 plus 4. You guys with me on that one? 10 squared and 2 squared. 100 plus 4. And because you're solving for the long side, it's very straightforward like that. Now the next one, you have a 6-meter ladder, and it's placed 1.2 meters from the base of a building. So you have some building. This is some building. I don't know. And then you got this ladder, like this. This is how far up will the ladder reach. So what you're looking for is some height. This is what you're looking for. It's a 6-meter ladder, and it's 1.2 meters from the base. So this one's a short side. So remember, you can't add on this one. You have to subtract. So go ahead and try this now. Okay, so this one is a short side Pythagoras. So with my shortcut, I just need the 6 squared, and then I'll take away the 1.2 squared. If that's a little bit fast for you, remember this example here. Remember, if you're solving for the short side, you're going to have to subtract. And what'd you guys get for an answer? 5.88, roughly. Okay, so we'll take a break and we'll go get textbooks. So we only have one more page left. Finish off this Pythagorean theorem. All right, so flip the page. All right, let's take a look at this one. Now on this one you have 2 right-angled triangles. Do you see them? There's one on the left and there's one on the right. And you butt them up side by side, and together they make a larger triangle, but you can visualize 2 right-angled triangles there. And they want you to find x. What's the problem though when you go to try to find x? You want to use y, but y is unknown, and then how could you get x? So this is an example of a 2-step problem. So clearly, you need to find y first. So find y. First of all, identify, is y a long side or a short side? It is a leg, so it is a short side. So do you add or subtract? You will subtract. Good. So we know that for y, I'll do this one longhand just in case you're forgetting. The long side squared will be equal to the 2 short side added up when they're squared. So this is 81. This is 36. And here comes the subtraction. And then we'll have to square root that result. So 81 take away 36 is 45. So this is what we're looking for. The square root of 45. And I got about 6.7. Any issues there? Now when we go to find x, what I want you to do is when you substitute in that 6.7, I want you to take a bunch of decimals, okay, so that you're accurate. So we know that x is the long side. Do you agree? Is x the long side? So then we'll have it alone on the left with 3 squared and y squared. We can sub in. I'm going to take a few decimals with me, 6.708. And that's from the previous answer. And I just take a few extra decimals for accuracy. And on this one, actually, because I can copy paste, I get all the decimals. So I can square that. It becomes 45 again. Then I can add 9, and then I can square root 54. And I get 7.35 roughly. Jackson, did you get that? Did you? You got that, right? You guys okay there? Now the next one is about a square, but they gave you the diagonal. So there's a square. There's the diagonal, and it tells you the diagonal is worth 13. So this is diagonal. And it says find the length of the side. Now this one gets interesting because if this side is x and it's a square, what's this side? Also x, because it's a square. Length and width for the square are the same. So now when we do our Pythagorean theorem, the long side, remember the long side is across the 90. So 13 square will be alone on the left. That's the c square. And then here we have an x square plus an x square. Now I will ask you a question, completely unrelated, maybe. What is 1 apple plus 1 apple? 1 apple plus 1 apple is? 1 and 1 make 2. What is 1x plus 1x? 2x. What is 1x squared plus 1x squared? Beautiful. So this left side is 2x squared. 13 times 13, 169. 169 equals 2x squared. So, back to our speak of algebra. What to do? Isolate x. How? What's in the way? There's a 2 in the way, and there's an x square. The square is in the way. So which one should we deal with first? It's sort of like reversed bed mass in a sense. Let's just get rid of the 2. How can I get rid of that 2? How can I move it to the other side? Divide. Very nice. Why is it divide? Because this is 2 times x squared. And what is the opposite of times? Divide. So a lot of people will do this. And what you do to one side, you do to the other. The other way you can think about it is if 2 is multiplied on the right, I can pick it up and move it. 2 is a divide on the left. So if it's upstairs on the right, 2 is downstairs on the left. Either way that you think about it, you will have 169 divided by 2 is equal to x squared. 84.5. And now we can do the opposite of squaring, which is square root both sides. I got 9.19 about. So it's Pythagorean theorem, but there's some algebra in there and some problem solving. So while Pythagorean theorem is a pretty simple idea, make sure that you have some problem solving abilities as well. And most of the time it just comes down to algebra. Do I know what x squared plus x squared is? And can I finish that off? Okay, now this one's tough because of 3D visualization. I think your generation might be a bit better than my generation with all the video games nowadays. But you got a 3-dimensional picture on a 2-dimensional page, so try to make sense of this. We want to solve for the length AB, which is the diagonal that goes through the interior of the box. So it's a 3-dimensional box, and they're from one diagonal to the other. So we want this guy. That's the one we want. So the double arrow, or the double line, that's an unknown. We need to find that first to use the double line and 12 to get this guy here. Now I already talked about the 3, 4, 5 triangle. Do you guys remember that one? So what is the double line? This is 5 right here. Do you guys remember that one? 3 squared plus 4 squared. 9 plus 16, 25. And then you have to square root that to get 5. You guys remember that from the start of the lesson? So the 3, 4, 5 triangle is very famous. These are called Pythagorean triples. They have special name. There's lots of them. And the 5, 12 is actually another famous one. 5, what happens when you square 5? You get 25. What happens when you square 12? You get 144. Add those up, what do you get? 169. And we've seen 169. What does 169 go to? 13. So I did that one a little bit quick. If you want to do that one by yourself with all the algebra, you can go ahead and do that. But those are the answers. And your homework for today is this assignment at the bottom called Worksheet. It's a pretty fancy name, Worksheet 1 through 8, and you'll find it on the very next page. And there's 8 questions, and there's some answers at the bottom. So good luck.